It was horrible. Like, I couldn't believe how cold it was. But I was like, hey, it's a great day to do some demonstrations on heat transfer. But it was really, really cold, and I was driving around, and all of a sudden, I got back to the school, and my flowers were wilting like crazy. And so, yeah, they're horrible. But this kind of goes to show you, if it is really cold on Saturday, and you are buying flowers for somebody, make sure you keep them in a really warm environment. Like, I turned my car off, so I'm pretty sure my car got really, really cold, and the flowers took a huge hit on that. And so, oh, poor little guys. But, you know, they're all right. So just kind of be a little cautious when you're taking your flowers out into the cold. They'll definitely die because of how cold it is. So I need 2 volunteers. I need a girl and a guy. Okay, Cade and Lydia, all right. I will actually have you guys put on some gloves. Mr. Klein will give you some gloves.
You head over with Mr. Hackett. Just
all right, so we're going to do a little role-playing act, okay? All right, so we're going to pretend that you bought some flowers. And Lydia and Cade are dating, okay? And they're Valentine's Day. Did you tell her what she's doing?
I hope I did.
Okay, okay. Basically. Okay, cool, cool. All right. Oh, hey, Kate, how's it going?
Good, but my flowers are a little wilted.
What happened to them?
They're a little cold.
Did you leave them out in the car too long?
Yeah.
Is it for your girlfriend?
Yep.
I think I have a way to solve our problem, Kate. Have you ever seen Frozen?
Yep.
Does your girlfriend like Frozen?
Yep.
Maybe she'll like some frozen flowers, eh? So what we're going to do is put those flowers in here. You got to keep them in there a little longer. What they're going to do is really cold, okay? The organic material in there is going to freeze, just like it would on your hands. You'll take them over there, and they'll be basically smoking, it looks like. There'll be those frozen flowers. You can never buy these in the store, okay? Hy-Vee don't got nothing on us, all right? Do, 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 do. There we go. All right, let's take them out. Take them out. Show her.
Here you go.
Oh. I hate you. Oh.
So,
That's really cool.
good job, good job. So why did they break?
Because they're brittle.
Very, very brittle. And the organic matter, okay, is going to break very, very easily, all right, because of the fact that everything's slowing down, it's losing thermal energy, but also what's inside of a lot of flowers?
Seeds. Water.
Water, water. And what happens to water? Freezes really, really fast. And so the organic material, the water, this same thing could happen to your fingers, okay? And so that's why we had to wear some gloves. But did you get the chance to like squeezing? You're like, oh my gosh, like crazy, right? So I'm actually going to do another one, just because that was a smaller flower, but I'm going to try and get a bigger one. So thank you guys for that. Gosh, I can't get over how well these smell, but they're like dead. This is probably the first thing I've ever smelled that was dead and smelled great.
Nora would love them.
Yeah. So I'm going to break them. If you didn't get a chance to see it, I'm going to break it over here. I'll have Mr. Klein kind of hold these and get these really frozen for us. But we're going to go over that first question, 3A, okay? 3A. When I dunk the flowers into the liquid nitrogen, what happens to the cellular components in the flower? Okay. Talk to me about what happens to the heat in the flower.
Transfers into the nitrogen.
Good, perfect. It transfers into the liquid nitrogen, all right? And because of this, it becomes very, very what?
Cold.
And what happens to the flowers? They
Brittle.
become very brittle. There you go. That's the word I was looking for. Okay? So very, very brittle material breaks very easily. So he's going to go ahead and squeeze them.
I don't like glass.
Yeah.
Oh.
So, kind of cool. The flower petals themselves are already very delicate, but by doing this to them, it's going to put them in harm's way, and they are going to sound like that glass, because it's literally, if you think about it, a bunch of liquid inside of there that just has frozen completely all the way
If you
through.
do that to someone's hand, could you like just crush it?
So yeah, exactly. And we're actually going to do we can do a marshmallow.
Can we do that to like people?
Marshmallows are really, really, you know, squishy
Yeah,
and
I'm kinda
fun
scared.
to play with. But if we put them in liquid nitrogen, they get really hard, really fast.
That's what Lenny should have done.
And this is a side demo, so we're not really. I'm going to make sure that you're up at the right spot on your paper. Okay. 3B. We should be able to finish with 3B. Why is it easier for me to crush the flowers when I place them in the liquid nitrogen as opposed to doing this right here? Come on, crush, come on.
He's just not as strong as I am.
Because they are frozen, and again, they become very, very brittle, all right?
Why if we did that paper?
What's that?
Why if we did that paper?
What if we did it to paper? I don't know if paper would have a huge effect. Some things don't really have a lot of effect. The great thing about marshmallows, they have a lot of air inside of them, and the molecules themselves will crush.
You want to?
Yeah, so I'm not going to hit it too hard because I don't want to spray it out like this, but
Oh.
Is it still good to eat?
okay, so imagine if that was, oh yeah, you could eat it, yeah, but you can't eat it now, it's too
This is how
cold.
they make Dippin' Dots. They throw
Yep.
ice cream into liquid nitrogen, and then it forms little bubbles.
Yep, this is how they make Dippin' Dots, yep.
Really?
And then they just crush them?
Little balls. No, they actually form balls. They have a machine that puts little droplets and freezes them instantly.
Another application for liquid nitrogen and food is if you've ever, maybe for example, up in Iowa City there's a place called Martinis, and they serve a bunch of martinis. It's a drink. It's a classy drink, and obviously they do have alcohol in them, but sometimes, for example, what they'll do is they'll take dry ice or a liquid nitrogen type of thing, and they'll bring it out to the person, and you'll see smoke coming out of the drink itself, and over time, you just have to wait for that smoke to go away, but it's the effect. You know what I mean? When you have a drink that's coming to you, and it actually has smoke that's being produced, or that vapor that we talked about, it's actually something that looks cool. You can't drink it, because if you were to get a lot of it, if you were to get any of that in your mouth, that would cause some problems. But it doesn't change the effect. It's just for the effect piece. So the next part, I think is it the racquetball?
No, it's actually.
No, the socket. Okay, the socket. So I have a metal ball and socket, and they do not go through each other. Okay, so what we would need to do is
Cool the ball down.
cool the ball down, and I tried that last time, and it was really tough because I've been using these so long. So what I'm also going to do is, if you can answer the next question, it says here, with the dry ice. So 4, why does the metal socket not go through the metal, go over the metal ball? Why does the metal socket, which is this, not go over the metal ball?
Because the ball's too big.
Because the ball is currently too big, exactly right. The ball currently is too big. So what's a way that we can actually have the ball go through the socket or the socket go over the ball?
You could heat up the socket and put the freeze ball. So
Perfect, okay? So this is what we're going to do. We're going to heat up the socket, and we're going to freeze the ball, okay? So this is actually going to be the last question on the very bottom part. Do you guys see that? So I'm going to freeze the ball. we're at negative 320 degrees Fahrenheit. Okay, this is probably, oh gosh,
You got the gun.
I have the gun. Let's check out what this is going to be.
Drops in.
160, 170 degrees Celsius. So if we were to convert that, .300 degrees Fahrenheit right now. 300 degrees Fahrenheit over here, negative 300 over here. And we can just check that out as well. And it's like giving me an error button, because it's like, what the heck are you pointing me at? You can't go that low. It says too low on it. And this doesn't take a long time, but it does in a way, because we're heating up and we're cooling down metal, which takes a lot longer to change, okay? But I think we should be good to go.
Whoa.
Okay? Good to go. And we can, just put these over to the side. So that's it, all right? Next question is what? I think it's the racquetball one. Yeah? So I only have one racquetball, and has anyone ever played racquetball before?
Yeah.
Yeah? It's pretty fun. It's actually really, really, really tiring at times, because you get, especially if you play with somebody who's really good, because they like to hit the racquetball really low to the ground, and if it bounces more than a couple of times, then you're done. But very, very bouncy ball, made of rubber. And so, what do you think we're going to do with this?
Is it gonna get crushed?
We're going to freeze it. Yep.
You're gonna drop it into a break.
That was your intention.
Yeah. So we're going to drop it in here, and I think that's so cool. That's just like the best. Now, Christmas ornaments. Has everyone put a Christmas ornament on a tree before? No? Okay. Now, the Christmas ornaments I'm trying to refer to are those globe Christmas ornaments. You know what I'm talking about? Okay. Now, my mom hated it when I would ever put, for example, a Christmas ornament on a tree and it were to fall onto the ground. You guys, have you ever had that happen? No, we only have so many of those, especially if they were like the family heirloom ones, you know what I mean? But it was always a fun time to go through there and put the Christmas ornaments, but it wasn't always fun when those broke down, all right? So what's going to happen is this is actually going to form a very, very hard, rubbery substance, and it's very, very brittle, just like in the case of the flowers. And so if we apply enough force to the racquetball now, it will actually break very, very easily. It becomes very brittle, and that's always something that, is very interesting to see. There's air still inside of this rubber, so if the air gets pressurized enough, it can make this really cool popping noise, similar to what you would hear when those ornaments fall on the ground. So, or someone who's pretty good at throwing things. Okay, I saw, yeah, go ahead and come here, Abby. You're going to have to put a glove on your throwing hand. I know that sounds weird, especially if you played baseball or softball. Like, what? I have it on my office.
I was a catcher in softball, so I'm good.
So that's your throwing hand, right?
Yep.
Perfect. Okay, I have some extra liquid nitrogen. What do you think I should do with it? I don't want to wait for it to go away. Yeah, let's pour it on the ground, just like what Claire said.
Mystical effect.
That's what I said.
All right, so what you're going to do is you're going to throw it on the ground, okay? Right in front of us, all right?
We can't see it.
And throw it really, yep, throw it hard.
Hey!
So, you didn't break it all the way, but here's the
Can I
rest.
throw it again?
Here, let me do it. It warmed up too fast. But you can see that it actually split that apart. So,
It looks like a tennis ball.
Yeah, food by Hunter's head.
so the pieces, don't pick them up